Assalamu alaikum everyone. Welcome to Exam Essentials. Today we'll be discussing the most recent Edexcel International A-Level Pure Mathematics-3 May 2025 question paper. So without wasting any time, let's just dive right in. So here is our question number 1. We can see there are two functions fx and gx given. The fx function is equal to 2x divided by 3x plus 1 and the gx function is equal to 4 minus x squared. The domains of these functions are also given. Now for part A, we have to find the value of gf1. So for part A, we have to find the value of gf1. To find this value, we first have to calculate the value of f1, and we have to input the value of f1 into our function g, and that will give us the value of gf1. To calculate the value of f1, we have to put 1 in place of x in our function fx. So we can do that. We will write 2 into 1 divided by 3 into 1 plus 1. From the question, we know that fx is equal to 2x divided by 3x plus 1. In this part, I have just replaced each x variable with 1. We also know that the function gx is equal to 4 minus x squared. What we get from here is that g half. Now if we calculate the value of g half, we will get the value of gf1. To calculate the value of g half, we have to replace x in the function gx and we have to input half in place of it. So this will be 4 minus half x squared. So this will be equal to 4 minus 1 by 4, which is 15 by 4. Now for part B, we have to find the range of f. To find the range of f, let us first write the function f. We know that the domain for this function is x is either equal to or greater than 0. Now to find the range of fx, we have to find the set of all the outputs possible for our function f. To do this, we can take the help of a graph, or we can just write out the range from our understanding. At first, I will calculate the value of f at the boundary of the domain. The boundary of the domain is x equals to 0. So I will calculate the value of fx at x equals to 0. This would be equal to 2 into 0 divided by 3 into 0 plus 1. This will be equal to 0 divided by 1 or 0. Now we can see that this is a reciprocal function. Which means that the graph of this function will have a vertical and a horizontal asymptote. Now as we are calculating the range, we have to take into account the horizontal asymptote. So to find the equation of the horizontal asymptote, we have to divide the coefficient of x in the numerator with the coefficient of x in the denominator of our function fx. So the coefficient of function in the numerator of x in the numerator is 2 and the coefficient of x in the denominator is 3. This gives us the horizontal asymptote. From this we can write that fx is greater than 0, fx is greater than or equal to 0 but less than 2 by 3. As y equals to 2 by 3 is an asymptote, our function fx will not equal 2 by 3. So we will write that fx is less than 2 by 3. We will not write that fx is less than or equal to 2 by 3. If I draw a graph to represent our situation here, we can see that y equals to 2 by 3 is our horizontal asymptote. If I calculate the vertical asymptote, the vertical asymptote will be at minus 1 by 3. X equals to minus 1 by 3 is the vertical asymptote for this graph. We already know that there is a point, the curve passes through the point 0 0. We already know that. So our graph would be like this. Now from this we can clearly see that for the domain x is greater than 0, the possible outputs for our function f is greater than 0 but less than 2 by 3. So our range is correct. So this is the answer to part B. Now for part C, we can see the question that we have to find the inverse function of f. To find the inverse function of fx, we will first assume that fx is equal to y. This is for the convenience of our calculation. So we can write that we know that fx is equal to 2x divided by 3x plus 1. As we have assumed that fx is equal to y, we can say that y is equal to 2x divided by 3x plus 1. Now we can make x the subject of the formula. Making x the subject of the formula will give us the inverse function. So we can cross multiply. Now we can bring all the terms with x in it to the left, and we can move all the terms without the x to the right. Now we will take x common from both of these terms, and if we make x the subject of the formula, we get minus y divided by 3y minus 2. I can divide by minus 1 on both the numerator and the denominator, and this will give us y divided by 2 minus 3y. So x is equal to y divided by 2 minus 3y, and this is the inverse function that we need to find. Now we can write that f inverse of x is equal to x divided by 2 minus 3x. Notice that we have changed the symbol from y to x. The reason for this is that our inverse function is also a function of x. Our inverse function is not a function of y. That's why we have to change all the y variables to the x variables. So this is our answer for part C. For part D, we can see that we have to solve f inverse of x equals to fx. We have to find the values of x for which the inverse function of fx is equal to the function fx. So we can write the inverse function of fx is equal to fx itself. Now we can write out the individual equations. For fx, the equation is 2x divided by 3x plus 1, and for f inverse x, the equation is x divided by 2 minus 3x. We can now cross multiply. This would give us x into 3x plus 1 and 2x into 2 minus thrice x. We can now expand the brackets on both sides, and this will give us 3x square plus x on the left and 4x minus 6x square on the right. Now we will bring all the terms on the left. So 3x square plus 6x square plus x minus 4x equals to 0. So 9x square minus 3x is equal to 0. We can take 3x common. This will give us 3x into 3x minus 1 equals to 0. Now we can say that either 3x equals to 0 or 3x minus 1 is equal to 0. So x is equal to 0 or x is equal to 1 by 3. So now these two are the solutions to our equation f inverse x is equal to fx. We can check whether or not our answer is correct by inputting these values in our respective functions. And when we do that, we will find that the left hand side is equal to the right hand side, proving that our values are correct. So this is our answer for part D. So this concludes uh, our question number 1. We can now move on to question number 2. So this is our question number 2. We can see here that we have a function fx which is equal to 7 cos x minus 24 sin x. Now in part A we have to express fx in the form r cos x plus alpha, where r and alpha are constants and r is greater than 0 and alpha is within this range. We have to give the exact value for r, and we have to give the value of alpha in radians to 3 decimal places. So we can solve the question number 1. In part A, we have to write 7 cos x minus 24 sin x in the form r cos x plus alpha. From here we can see that we can expand this factor, we can expand this expression using the addition formula for cos. So we know that cos A plus B is equal to cos A into cos B minus sin A into sin B. We can use this identity to break down cos x plus alpha. So we can write r cos x into cos alpha minus sin x into sin alpha is equal to 7 cos x minus 24 sin x. We can further simplify this. R cos x cos alpha minus r sin x sin alpha is equal to 7 cos x minus 24 sin x. Now by comparing the sides, we can see that r cos alpha is equal to 7 and r sin alpha is equal to 24. By comparing the sides and by equating the coefficients for cos x and sin x, we get that r cos alpha is 7 and r sin alpha is 24. Now to find the value of r, we can square r sine alpha and add the square of r cos alpha. This will give us 7 square plus 24 square. Because r sine alpha is 24, I'm sorry, I've written it in the opposite way. So r sine alpha is 24 and r cos alpha is 7. So r sine alpha whole square plus r cos alpha whole square will be equal to 24 square plus 7 square. Now if I expand and simplify the left hand side, we get r square plus sine square alpha plus r square cos square alpha equals to 24 square plus 7 square. Now if we take r square common, we get that sine square alpha plus cos square alpha is equal to 625. Now if we try to remember this identity, sine square x plus cos square x is equal to 1. This identity can be used here. We can see that we have an factor sine square alpha plus cos square alpha, and this term is equal to 1. So we can write r square into 1 equals to 625. R equals to plus minus root 625. This is equal to plus minus 25. We already know that r is greater than 0, so r is equal to 25. So this is the value of r. For the value of alpha, we can use the identity sine theta by cos theta equals to tan theta. So we can write r sine alpha divided by r cos alpha equals to 24 by 7. We also know that we can cancel out r from the numerator and the denominator, and we know that sine alpha divided by cos alpha would be tan alpha. So tan alpha is equal to 24 by 7. We know that alpha is within the range 0 to pi by 4, pi by 2. 0 to pi by 2, alpha is within this range. There is only one value of alpha within this range, which is the value from the first quadrant. So tan inverse 1 of 24 by 7 would be so this will give us 1.287 up to 3 decimal places, and this is our answer for alpha. To calculate the value of alpha, we have used the identity that sine theta divided by cos theta is equal to tan theta. We have used this identity for this question. From this, we can now express our function fx in the form r cos x plus alpha. So we know r is 25, and we can write cos x plus alpha, which is 1.287. Now for part B, For part B, we can see that we have a function gx given, and gx is equal to 5 divided by 90 minus 3 into f2x. So we can see that our function gx depends on the value of the function 2x, which is just the graph of fx, but uh, that is horizontally halved. Now in part B, we have to find in part 1 we have to find the minimum value of gx, giving our answer as a fully simplified fraction. So for part B1, we have to find the minimum value of gx. We know that gx is equal to 5 divided by 90 minus 3 f2x. We know that f2x is a horizontal compression of fx, so they will have the same y coordinates. There will be no change in the y coordinates for both of these graphs. From the equation we can see that for gx to be maximum, the denominator of this graph, for gx sorry I'm sorry the for gx to be minimum, let me check again. Yes, we have to find the minimum value of gx. So for gx to be minimum, the denominator of this function must be in its maximum value. The denominator must be in maximum value for the function gx to be in its minimum value. So for uh, for maximum denominator, for the maximum value of denominator, we can find the minimum value of our function f2x. We can write minimum value of f2x will equal, first we will write the expression for f2x. We know that fx is 25 cos x plus 1.287. So we can write that f2x is equal to 25 cos 2x plus 1.287. We can see that the maximum value will not change because this is not a vertical translation nor it is a vertical stretching. So the maximum values will not change. We are trying to find the minimum value of f2x. So for the minimum value of f2x, we can say that the minimum value is minus 25. So we can write that minimum value is minus 25. We can input this value into our function. So 5 divided by 90 minus 3 into minus 25 would give us the minimum value for gx. This when calculated will give us 1 by 33, and this is the minimum value of gx. Now for part 2, if we read the question, we have to find the smallest positive value of x for which this minimum value occurs, giving you an answer to 3 zeros. So we have to find the value of x for which this minimum value occurs. We know that this minimum value occurs when our function f2x is at its minimum value. So we can write f2x is equal to 25 cos 2x plus 1.287. Now we know that at minimum value we have minus 25 equal to 25 cos 2x plus 1.287. Now we can find from here that minus 1 equals to cos 2x plus 1.287. Now this will give us 2x plus 1.287 is equal to cos inverse 1 of 1. In our case it is negative 1. This will give us pi and 2 pi is positive and many other values. From part A we knew that the period for our function, the range for alpha is from 0 to pi by 2. Here we can see that we have to if we can see the information about the period, no information is given certainly, so we can discard this. So as we are told to find the smallest x value for which this minimum value of gx occurs, we only have to use pi. We do not need to calculate any other values for which cos is equal to minus 1, cos x is equal to minus 1. We do not need to find any other values for which cos x is minus 1. We just need to use the value pi. So we can write 2x plus 1.287 is equal to pi. So 2x is equal to pi minus 1.287. So x is equal to pi minus 1.287 divided by 2. And this is equal to this gives us 9273, and we have to keep it 3 decimal places. So our answer is 0.927. X is 0.927. So this concludes our question number 2. We can now just move on to question. So here is our question number 3. We can see that figure 1 shows a linear relationship between log10 y and log10 x. So this graph that we're given here is a relationship between log10 y and log10 x. We can see the graph is a straight line and it passes through the points minus 3.5, 0 and 0 minus 2. Now for part A, we are told to find an equation linking log10 y with log10 x. So if we have to find an equation linking log10 y and log10 x, we can just try to find the equation for this straight line. If we find the equation for the straight line, we can relate log10 y and log10 x. The x and the y variables in the equation of this line will be log10 y and log10 x respectively, because the variables in this graph has been changed. The variables are no longer x and y. The variables are now log10 x and log10 y, where log10 x is the independent variable and log10 y is the dependent variable. That's why if we find the equation for this straight line, this straight line the straight line will be a relationship between log 10 y and log 10 x. So for part A, we can just find the equation of the straight line. To find the equation for this straight line, we have to find the gradient of this line, and we have to find and we have to use a single point on this line, a single known point on this line, and then we can find the equation for this line. So first of all, let me calculate the gradient for this line. M gradient for the line will be equal to y2 minus y1 divided by x2 minus x1. To calculate the value of gradient, I will use two different points on the line which are given minus 3.50 and minus 20. Let me check. Sorry, it's 0 minus 2. It's 0 minus 2. So 0 minus 2. These 2 points will be used to find our gradient. So let's say minus 2 is our y2. So 0 would be our y1, and then for x2 it will be 0 minus of minus 3.5. This becomes minus 2 divided by 3.5, and ultimately our gradient is minus 4 by 7. Now we have to find the equation of the line, because of the equation of the line will give us a relationship between log 10 x and log 10 y. We know the general formula to find the equation of any line is y minus y1 equals to m x minus x1. We know m is minus 4 by 7, and we also know a point on the line. Let's say the point I use is 0 minus 2. We know from here that the y variable in this particular case is log 10 y instead of y, and minus y1, which is minus 2, equals to m, which is minus 4 by 7, into x. We know that instead of x, in this particular case we have log 10x as our independent variable, minus 0. Now if we simplify this, we get log 10x, and ultimately if we make log 10 y the subject of the formula, we get log 10x minus 2. This is the equation that links log 10y and log 10x. So this is our answer to part A. For part B, we have to express y in the form px to the power of q, where p and q are rational constants. To do this, we have to convert this term from the log form into the exponential form. Doing this will give us an expression for y in terms of powers of x. So for part B, we can write log of 10y equals to minus 4 by 7 log 10x minus 2 log 10. Then we can write log 10x to the power of minus 4 by 7 minus log 10 square is equal to log 10y. Again, we can write log 10y is equal to log 10x minus 4 by 7 divided by 100. From here, from the first step, in the first step, I have written 2 into log 10 because we know that log 10 is equal to 1. So log 10 into minus 2 would be equal to minus 2. So our equation is our equation does not change. In the next step, I have used the laws of logarithm to move what is before the log and write it as a power of log, because we know that log a to the power of something is equal to the power into the log of that thing. So we have used this to write this part. Then I've used the quotient rule for log, where it states that log of a minus b, where it states that log of a by b is equals to log of a minus log of b. So I have used this identity to transform our log with two terms into a log with one single term. The reason we are doing this is so that we can bring log with the same base on both sides of our equation, and then we can compare uh, the sides, and we can equate y. So from this we can say that y is equal to x minus 4 by 7 divided by 100. And this is our answer. And we can simplify and write 1 by 100 x to the power of minus 4 by 7 is equal to y. And this is our answer to part number B. Now we only use the laws of logarithms to solve this part of our number 3, question number 3. So this is the answer to our part B. We can now move on to part 4. So here is our question number 4. We can see that we are given a function fx which is equal to 49x divided by x square plus x minus 12 plus 7x divided by x plus 4. And we are also given that in this function x is greater than 3. So the domain information for this function is also given. Now we have to show that fx is equal to 7x divided by x minus 3. Now, what we can notice here is that the final function or the final expression that we need to derive is much more simpler than our original function fx. This means that we have to simplify this expression. We have to simplify and factorize, and whatever we need to do to simplify this equation. We can also notice that the final expression is a single fraction. What this means is that we have to combine the fractions to achieve this result. So let's start solving this. So for part A, we know that fx, or our function, is equal to 49x divided by x square plus x minus 12 plus 7x divided by x plus 4. Now I can see that the denominator for this fraction is a quadratic equation, which means that I can factorize this quadratic equation to further simplify it. So now we will factorize this quadratic equation by using middle term so that it becomes further simplified. So I can write x square plus 4x minus 3x minus 12 as the list of terms, and I can write 7x divided by x plus 4 on the right. Further simplification will give us, if we take x common from the first two terms, we get x plus 4 minus 3 x plus 4 plus 7x divided by x plus 4. Now we get 49x divided by x minus 3 and x plus 4 as our simplified fraction here, and we get 7x plus x plus 4 divided by x plus 4 here. Now we have to combine the fractions, because we saw that in our final equation, in our final expression, there is only a single fraction, so we need to combine these fractions together. To combine these fractions, we can take the LCM of the denominators. The LCM of the denominators will be the common factor into the uncommon factor, and this is the LCM for both of them. Now if I'm going to write the numerator of this combined fraction, I will have to divide x minus 3 and x plus 4 with it, which will give me 49x, and then doing the same, dividing x plus 4, dividing our LCM by x plus 4, and then multiplying the results with 7x will give us 7x into x minus 3. Further simplification will give us 7x square minus 21x divided by x minus 3 and x plus 4. Now if we simplify further, we get 49 minus 21 plus 7, so we get 28x plus 7x square divided by x minus 3 and x plus 4. Now we can see that in the numerator we can take 7x common. 7x is common between both of them, between both the terms, so we can write 7x into x plus 4 as the numerator and x minus 3 into x plus 4 as the numerator. We can see that there the two terms x plus 4 is present in both the numerator and the denominator, so we can cancel them out. Before cancelling them out, we have to make sure that x plus 4 is not equal to 0. If x plus 4 is equal to 0 at any particular value of x, then we cannot cancel them out. We have to make sure that at any particular value of x, x plus 4 is not equal to 0. And this is what happens here, because we know that x is greater than 3. If x is greater than 3, there is not a single value in the domain of x that will make x plus 4 equal 0. That's why we can cancel them out, because there is not a single value of x in its domain that will make the term x plus 4 equal 0. Ultimately, we can write 7x divided by x minus 3 as our simplified fx. And this is our answer to part A. For part B, we have to find the derivative of this function, or the differentiate. We have to differentiate this function. So for f prime x, we have to differentiate this function, 7x divided by x minus 3. We can see that we cannot further simplify this fraction. This fraction cannot be simplified into 2 or 3 terms of x. As it cannot be simplified into terms of x, what we have to do is we have to apply the product rule to differentiate this function. Using the product rule, we get that when using the product rule, we find how we can do this. First of all, we have to square the denominator. Then we have to multiply the denominator with the ddx of the numerator, which is 7x. Then we subtract the numerator into the product of the denominator, which is x minus 3. Simplifying this, we get into 7 minus 7x into 1 minus 0. Here ddx of 7x is equal to 7, and ddx of x minus 3 is 1 minus 0. ddx of x is 1 and ddx of minus 3 is 0. Ultimately, simplification will give us 7x minus 21. I have expanded the brackets here, and then we on the right we get minus 7x divided by x minus 3 whole square. So 7x and 7x is cancelled out. This gives us minus 21 x minus 3 whole square. This is our answer to part B. This is our answer to part B. So this concludes our question number 4. We can now move on to question number 5. We can see that in question number 5 we have two parts, part 1 and part 2. In part 1, we have to find the integration of sine squared 3x. So in part 1 we write we have to find the integration of sine square 3x dx. To find this integration, we have to first understand that we cannot integrate trigonometric functions that have a power greater than 1. So sin square x has a power greater than 1, cos square x has a power greater than 1, tan square x has a power greater than 1. This type of functions cannot be integrated directly. We have to write out an identity. We have to write sin square 3x into an equivalent identity where the trigonometric function will have a power of 1, or the function will be linear. In other words, we have to convert, or we have to write out this term as an equivalent term that has a linear trigonometric function, that has a linear trigonometric term. So how can we do this? How can we convert sin square 3x into an equivalent linear trigonometric form? To do this, we can use identities, specifically the identity of cos 2x. We know that there are many forms of many ways to write the identity of cos 2x. We know that cos 2x equals to cos square x minus sin square x. We also know that cos 2x is equal to 1 minus 2 sin square x. For this particular question, we will use the second form. From here, we can see that if we make x squared the subject of the formula, we get cos 2x minus 1 equals to minus sin square x. And now if we make sin square x the subject of the formula, we will get cos 2x divided by minus 2 minus of minus 1 by minus 2. This will give us half minus half cos 2x equals to sin square x. So this is our identity. This is the identity that converts sin square x into cos 2x, and cos 2x is a linear term. Now what we can do is we can adjust the formula for sin square 3x. We have already written the identity for sin square x. Now we have to write the same identity but for a different angle, which is 3x. We can see x is increased by 3 times. So what we have to do is we have to increase the argument of every trigonometric function by 3. So before it was cos 2x, now it would be 2 into 3 6x, and and this is what gives us an equivalent identity for sin square 3x. We now know that sin square 3x is equal to half minus half cos 6x. Now what we can do, we can just substitute this value into our equation. So in place of sin square 3x, I will write half minus half cos 2x dx. I'm sorry, it would be cos 6x dx. Now we need to integrate. So integrating half would equal half x minus half. The integration of cos is sin 6x divided by the differentiation of 6x, which is 6, plus the constant of integration, which is c. So this is our integral. We just need to simplify this. So half x minus 1 by 12 equal into sin 6x plus c. This is our answer to part A. I'm sorry, part 1. We will now move to part 2. Now for part 2, we have to integrate x into x square plus 4 to the power of 3 by 2 dx. Now when integrating this, we can see that the power on this factor is 3 by 2. We cannot expand this. If we expand this, if we expand the brackets, we will get the infinite number of terms. So we cannot expand there is no way to simplify this. So to do this type of integration, what we can do is we can use substitution method. We can assume a part of this function as u, and then we can substitute du by dx and other terms here to simplify this expression. We can simplify this expression to the point that we can integrate it normally, and that will solve our integration. So for this particular equation, I'm assuming that x squared plus 4 is u. Now I will take the derivative of u. This will give me 2x plus 0 or 2x. I can now separate out the terms. So du is equal to 2x dx, or half du is equal to x dx. Now if I rewrite my equation as this, which is of course equivalent to the first one, we see that we can replace x dx with du, and we can replace x squared plus 4 with u. So let's simplify this. U to the power of 3 by 2 du. This is our simplified equation. Now we can integrate this normally and easily. The integration for this would be 3 by 2 plus 1 divided by 3 by 2 plus 1 plus c. Simplifying this will give us 5 by 2 divided by 5 by 2 plus c. Again, if we simplify it for the last time, this will give us 2 by 5 u to the power of 5 by 2 plus c. So this is our equation. So this is our answer basically, but we have to, in the last step, we have to resubstitute the value of u into our final expression for integration. We already know from the question that u is equal to x squared plus 4. I'm sorry, we assumed that u is equal to x squared plus 4. So we now have to resubstitute, kind of back substituting. So we will resubstitute the value of the expression for u. So x squared plus 4 to the power of 5 by 2 plus c. This is our answer, our final answer for part 2. Now this concludes our question number 5. We can now move to question number 6. So for question number 6, we can see that the temperature theta degree Celsius of a computer processor t minutes after the computer is switched off is modeled by the equation. So in question number 6, we have a computer processor whose temperature after being switched off has been monitored and has been modeled by this equation. From intuition, we can say that the temperature of the computer processor will decrease over time because the computer is switched off. So it will become colder and colder. So the temperature of a computer processor after the computer is switched off will constantly decrease. And this is given by the modeling equation here. Theta equals to 21 plus a into e to the power of minus kt. We can also see that it is given that a and k are positive constants in our equation. What this means is that only theta and t are the variables in our equation. Anything other than that are constants. Now, given that the temperature of the processor was 75 degrees Celsius when the computer was switched off. Now, for part A, we have to find the value of A. We can see here that in part A we have to find the value of A. I have taken the information from our question. It says in the question that at time equals to 0, when the processor is turned off, that is time equals to 0. The instant that the processor is turned off is what we call time equals to 0. So at time equals to 0, the temperature is 75. Basically, the initial temperature is 75. So what we do is we substitute these values into our equation, and that gives us the value of A after simplifying. Now for part B, we see that given also that it takes 5 minutes for the temperature of the processor to decrease from 75 to 25. Find the value of K, giving your answer to 3 significant figures. For part B, we can see that our temperature is 25 and the time when this occurs is 5 minutes. So we can just substitute this into our equation. At first, I have modified this equation here. I have substituted the value of A to find this new equation where there is only one unknown, which is K. So now we resubstitute the values. 25 equals to 21 plus 54 e to the power of minus 5k minus 5k. Now upon simplifying we get equals to e minus 5k, and this gives us 25 minus 21. Then 54, this gives us 2 by 27. We can take ln for both sides. So ln of 25 minus 21 divided by 54 will equal minus 5k. Why did this happen? Because we know ln of e minus 5k would be equal to minus 5k ln e, and ln e would be equal to 1. So our ultimate answer is minus 5k. Ultimately, the value of k would be minus 1 by 5 ln of 25 minus 21 divided by 54. So this gives us a value of 0.52 0537, and it goes on. Now from the question we can see that we have to keep the value of k to 3 significant figures. So we are going to keep the value of k to 3 significant figures, and this is our final answer for part B. Now for part C, we see that at time t minutes the temperature of the processor is decreasing at a rate of 9 degrees Celsius per minute. Find the value of t according to the model, giving answer to 3 minutes per second. Now to find the rate of change of temperature, we need to differentiate this equation. So for part C, we know the original equation is theta equals to 21 plus 54, and I'm substituting the value of k into our equation. This will be 0.521 t. This is our final equation without all the unknown constants. This is our final equation with all the known constants. So now if we differentiate this equation, this will give us the rate of change of temperature per unit time at every single point on our curve. So if we find d theta by t, we find that the ddt of 21 would be equal to 0 plus ddt of 54 e to the power of minus 0.521 t would be equal to 54 into e 0.521 t into the ddt of minus 0.521 t, which would be equal to minus 0.521. And we are multiplying this together. So the ultimate answer would be this will give us minus 28.134 e to the power of 0.521 t. Now in the question we are told to find the temperature, or to find, we are told to find the time at which the temperature of the processor is decreasing at a rate of 9. This means that we have to find the time for which our d theta by t value would be equal to 9. Our rate would be equal to 9. So what we have to do is we have to equate d theta by t with 9. And if we solve this equation, we will find the time for which the value of this would equal 9. So we can write minus 28.134 e minus 0.521 t is equal to 9. Further simplification will give us 51 t is equal to 9 divided by minus 28.134. Now what we can write is that we can take a ln on both sides. And this will give us now before taking ln, I can recheck the equation and I find out that I've written this wrong. Sorry for this mistake, but we are told in the question that the rate of decreasing is 9. The rate of decreasing is 9. So when we are writing, we have to input a negative sign here. This gives us a negative sign everywhere. And now we can take ln. Taking ln on both sides would give us minus 0.521 t on one side and ln of 9 by 28.134 as on the right. So this gives t. So t is equal to minus 1 by 0.521 ln 9 of 28.134. This will give us and this gives us a time of 2.8176 and a lot of more values. We can keep the time to 2 decimal places because it is how it is mentioned in the question. So we will keep the time to 2 decimal places. Keeping the time to 2 decimal places will give us 2.19. The value before rounding would be 2.1876, 2.1876, and so on. So this is our final answer for part C. Now this concludes our question number 6. We can now move on to question number 7. So in question number 7, we can see that we are given an equation of a continuous curve. The equation is y equals to e to the power of minus x square into sine 3x, and the domain for this equation is also given. Now it is said that the curve has a stationary point at point P. So the curve has a stationary point at point P. What this means is that the gradient of the point P on that curve is 0. What this also means is that if we take the derivative of our function and we calculate the derivative at point P, we will see that the derivative equals 0 at that point. Now for part A, we have to show using calculus that the x coordinate of P is a solution of the equation x equals to 1 by 3 arctan of 3 by 2x. Now it is said that we have to show using calculus that the x coordinate of P is a solution of the equation. What this means is that we have to try to solve and find the x coordinate of P. To do this, what we have to do is we have to find the derivative of our function, and then we will find out the stationary points of our equation of our curve, and one of the stationary points will be P. The equation that gives us the stationary point will be our answer. So we can start solving this. For part A, we have to first write out the equation. Now we take the derivative. When taking the derivative, we can see that this function cannot be simplified into simpler terms or algebraic powers. That's why what we have to do, we have to use the product rule to differentiate this. Using the product rule, we have to multiply ex square with the derivative of sine 3x, and then we have to add sine 3x into the ddx of e minus x square. Simplifying this, we get that the differentiation of sine 3x would be cos 3x into 3 into 3 plus sine 3x into differentiation of e to the power of minus x square, which will give us e to the power of minus x square into minus 2x. Simplifying this, we get and we can write minus 2x sine 3x e to the power of minus ax square. Again, after simplifying, we get minus 2x sine 3x e to the power of minus x square. So this is the answer to the differentiation. So if we see, what we have done here is we have taken each function and we have multiplied. We've used a product rule basically. The product rule states that if a function is represented as u v, where u and v are the product of two different functions of x, so dy by dx would be u into d dx of v plus v into d dx of u. This is exactly what we have done here. We have taken the first function and we have multiplied the derivative of the second function, and then we have added the second function and we have multiplied the different derivative of the second function. For the first function, we have differentiated sine 3x and we have used the chain rule to differentiate this. So when we use the chain rule, we can write that ddx of sine 3x is equal to cos 3x, but then we have to multiply the derivative of the 3x, which is 3. And then for the second term, we see that we have to differentiate e to the power of minus x square. E to the power of the differentiation of e to the power of minus x square will be equal to e to the power of minus x square, but then we have to multiply the derivative of minus x square. The derivative of minus x square is minus 2x. This is where this term comes from. This is the derivative of that function. So derivative of minus 2x square is equals to minus 2x. This is where this comes from. Now it is said that we have to find out the stationary point P. We have to find out the exponent of the stationary point P. Now to find the stationary points in general, what we have to do is we have to equate the dy by dx for a function with 0, and we solve this equation to get the values of x for which our function shows a stationary point. We can write dy by dx is equal to 3x e to the power of minus x square minus 2x sine 3x e to the power of minus x square. This is equal to 0. Now we can move this term to that side. So 3 cos 3x e to the power of minus x square is equal to 2x sine 3x e to the power of minus x square. Now if we simplify further, if we can simplify further, we can see that we have e to the power of minus x square and e to the power of minus x square in both sides. So what we can do is we can cancel them out, but we have to first make sure that e to the power of minus x square is greater than 1, is greater than 0 to be is greater than 0, sorry. So if we want to cancel out e to the power of minus x square, we have to make sure that e to the power of minus x square is greater than 0. And we see that this is definitely the case, because as this is a power function, as the base is positive, there is no power that will make that base equal 0. So that's why we can cancel it out. So our simplified equation stays as now we can further simplify 3 tan x, or I can write 3 2x into sine 3x divided by cos 3x. Now I can simplify further. I can use the identity tan x equals sine x by cos x to transform this equation. I can write 3 is equal to 2x into tan 3x, or I can write 3 by 2 is equals to x tan 3x. Again I can write tan 3x equals to 3 by 2x, or 3x is equal to tan inverse 1 of 3 by 2x, or x equals to 1 by 3 arctan of 3 by 2x. And this is what we have to show. This is what we show. So now for part B, we have to find, we are given an iteration formula xn plus 1 equals to 1 by 3 arctan 3 by 2 xn, where x1 is equal to 0.4. Now we have to find the value of x2 and x4, and we have to give our answers to 4 decimal places. Now in part B, we have to find iterations. So we first of all can write out the iteration formula. X plus 1 is equal to 1/3 of arctan 3 by 2 xn. Let me check again. Yes, this is our iteration formula. We know that x1 is 0.4. We have to find out x2. To find x2, we have to input the value of x1 into our iteration formula. So 3 by 2 into 0.4. This will give us this will give us 0.436731, and so on, and we will write up to 4 decimal places. So this will be equal to 0.4367. Then again for part 2, we have to find x4. To find x4, we have to first of all find x3. The third iteration will be 1 by 3 arctan, and then we have to input the value of x2 into our equation. So 3 by 2 x2. Doing this will give us doing this will give us 0.429158, and so on. Now to find x4, we will use the same formula, but instead we will input the value of x3 in this. So this will give us 0.430711 and so on, but we will keep the value up to 2 decimal places. So this will give us up to 4 decimal places. So 4307 is our answer. Now for part C. For part C, we have to use a suitable interval and a suitable function which should be stated to show that the x coordinate of P is 0.430 correct to 3 decimal places. Now for part C, if we want to keep our solution correct to 3 decimal, our solution 0.430 up to correct up to 3 decimal places, we have to find out the upper and lower bounds for which the values for which when rounded up the value will equal to 0.430 up to 3 decimal places. So we can find the upper limit. We can find the upper limit as 430 plus 0.001 divided by 2. This will give us the upper limit of 4305. We can find the lower limit. The lower limit and the upper limit means uh, it gives us the boundary for up to which the value of x can vary. The value of x can vary so that it can be said that x is equal to 430 up to 3 decimal places. So the lower limit is 430 minus 0.001 divided by 2, which again is 0.4295. So our suitable range is 0.4295 and 0.4305. This is our suitable range for this. Now we have to take a suitable function and we have to evaluate whether or not if we refer back to the question, we have to evaluate whether or not these values actually give us a solution to the equation. So we can write that the function that will help us test whether or not a solution exists within this interval will be this function x minus 1 by 3 arc tan 3 by 2x. This is our function. This function can be used to test whether or not a solution exists within these ranges or not. Now to check whether or not a root exists within this interval, we have to input each value for the interval inside our function, and we have to evaluate whether our function is positive or negative. If the sign changes between this boundary between these interval limits, then we can say for certainty that a root exists between these two interval limits. As a root exists between these two limits, we can for certainty say that x equals to 0.430 is a root up to 3 decimal places. So what we will do, we will calculate the value of f for the lower limit. So 4295, this will be equal to 0.4295 minus 1/3 of arc 10, 3 by 2 into 0.4295. This will give us a value of 6.38 into 10 to the power of minus 5. This is a positive value. This is a positive value. Now, if we calculate for the upper limit, 0.4305, we get that for the upper limit, we have to input 0.4305 plus 1/3 of arc 10, 3 divided by 2 into 0.4295 equals to minus 1.14 into 10 to the power of minus 3. So this is negative. Now we can see that sign changes between these two intervals. So that's why we can say that a root certainly exists between the two between in this interval, and the root is certainly equal to 0.430 up to 3 decimal places. So we can write the conclusion as sign changes between the interval x is equal to 0.430 is a solution up to 3 decimal places. So this is our answer to part C. And this concludes our question number 7. We can now move on to question number. Here we have to prove that for part A, we have to prove that tan 3x is equal to 3 tan x minus tan cube x divided by 1 minus 3 tan square x. So we can just start solving this. Now to derive this expression, we have to write down tan 3x as 2x plus x. Writing this will allow us to expand tan 2x plus x using that addition formula for tan. We know that tan a plus b is equal to tan a plus tan b divided by 1 minus tan a into tan b. This is the identity that relates the sum of two angles, the tan of sum of two angles, and its corresponding expression. So we can write tan 2x plus x and express it using this corresponding form. In this expression, 2x will be the a and x will be b. So we can write tan 2x plus x is equal to tan 2x plus tan x divided by 1 minus tan 2x into tan x. Now we can see here that in this expression we have a term tan 2x. We already know the identity for tan 2x. Tan 2x is equal to tan square x divided by 1 minus uh, tan square x. I'm sorry, it is 2 tan x. It is 2 tan x divided by 1 minus tan square x. This is the identity for tan 2x. So we can just substitute this identity into our expression for tan 2x. So we can write 2 tan x divided by 1 minus tan square x plus tan x as the numerator, and then we can write 1 minus 2 tan x divided by 1 minus tan square x into tan x as our denominator. Now if we simplify, we can take LCM and combine the fractions on the numerator, which will give us 1 minus tan square x as the denominator on the fraction on the numerator, and then we can write 2 tan x. I can write it around more clearly if I take a bit more space. So this will give us 2 tan x plus tan x into 1 minus tan square x. This is the result of combining the fractions together. Now if we do the same for the denominator, we get 1 minus tan square x as the denominator on the fraction of the denominator. So then we get 1 minus tan square x, then minus 2 tan square x. Now when simplifying this, we can see that we can cancel out 1 minus tan square x from the denominator of on the numerator and the denominator. We have two fractions, one in the numerator and one in the denominator. We see that in both of these fractions 1 minus tan square x is in the same position, so we can cancel them out. And we can simplify the numerators of the fractions. This will give us 2 tan x plus 10x minus tan cube x on the numerator of our fraction, and 1 minus 3 tan square x in the denominator. Simplifying further will give us 3 tan x minus tan cube x on the numerator, and 1 minus 3 tan square x in the denominator. This is our final answer. So now for part B, we can see that uh, we have an equation that is given 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta equals to 2 sec square 3 theta minus 8. And we have to solve this equation. Basically, we have to find the value of theta to two decimal places. The range of theta is also given. We have to use this to find the possible values of theta for which this equation is satisfied. For this, we need to simplify our expression before we calculate theta. So we will copy out the equation 3 tan theta minus tan square theta, tan cube theta divided by 1 minus 3 tan square 3 theta, theta, sin square theta is equal to 2 sec square theta 3 theta minus 8. This is the expression we are given in the question. We can see here the expression on the left side of our equation is exactly same as the answer we derived in part A. What this means is that we can use this identity to simplify our expression. So we can write that 3 tan theta minus tan cube theta divided by 1 minus 3 tan square theta can be written as tan 3 theta. This is equal to 2 sec square 3 theta minus 8. Now we can use the identity sec square theta equals to 1 plus tan square theta to further simplify this expression. We can see from this identity that sec square theta equals to 1 plus tan square theta. We see in our expression we have sec square 3 theta. So for sec square 3 theta, our identity would be 1 plus tan square 3 theta. So we can replace sec square 3 theta with 1 plus tan square 3 theta minus 8. This is equal to tan 3 theta. Expanding the brackets and simplification will give us 2 tan square 3 theta minus 8. Ultimately, this will be simplified to 2 tan square 3 theta minus 6 equals to tan 3 theta. Now, bringing all the expressions to one side will give us 0 equals to 2 tan square 3 theta minus tan theta minus 6. Now solving this will give us before solving we can notice that this is in the form of a quadratic equation. If we assume that tan theta is m, we can write out this expression as 2m square minus m minus 6. Now, as this is in a quadratic form, we can use the middle term method to factorize this. Using middle term method, we can write 2m square minus 4m plus 3m minus 6 is equal to 0. So 2m is common between the first two terms. So m minus 2 would be within the brackets, and then 3 would be common between the last two terms, and m minus 2 would be in the brackets. So 2m plus 3 and m minus 2 is the other factors for this expression. So we can write 2m plus 3 equals to 0 or m minus 2 equals to 0. M equals to minus 3 by 2 or m equals to 2. These are the values for true. Remember that we assume that tan theta is equal to m. So we now have to write that tan theta is equal to minus 3 by 2 and tan theta is equal to 2. Now we have to solve these equations for theta. We already know the range of theta is given as theta is greater than 0 but smaller than pi by 2. I'm sorry, we assume that tan 3 theta is equal to m. So here it will be tan 3 theta. So we know the range for tan for theta. We now have to find the range for tan for 3 theta. The range for 3 theta would be 3 theta is greater than 0 but less than 3 pi by 2. Now we can solve each of these equations to find a basic acute angle for the value given. So tan inverse of 2 would give us a value of, this is what we get when we find 3 theta from these expressions. Note that uh, when we find the angle 3 theta, I have not used the negative part of 3 by 2 of this expression. I've used the positive part, the magnitude of the part which is 3 by 2, to find the basic acute angle for 3 theta. Now we can write that as tan 3 theta for this part, as tan 3 theta is less than 0, 3 theta exists in first, and I'm sorry, as tan theta is negative, the value of theta must exist in second quadrant only. To be fair, it does also exist in fourth quadrant, but the fourth quadrant does not exist in our range. So we can write that 3 theta will be equal to pi minus 0.9828 or 2 pi minus 0.9828. This is beyond our range, so this value will not be acceptable. So we get that from here, we get that 3 theta is equal to pi minus 0.9828, which will be equal to 2.158788, which is again equal to, let me see the number of decimal places. We have to round up the values to 2 decimal places. So which is again equal to 2.16. We can divide before rounding up. So 2.1588 divided by 3. And this will give us 0.7196, which is equal to 0.72. And this is our answer from this expression. For the second expression, we have 3 theta is equal to 1.1071. This is the basic acute angle for the value 2. Then we can write as tan 3 theta is greater than 0. We can say that 3 theta exists in first and third quadrants. The reason why it exists in first and third quadrants, because tan is positive in only positive in first and third quadrant. I can mention the quadrants here. In the first quadrant, every single value, every single angle, every single function will give positive value. In the second quadrant, only sine function will give positive value. In the third one, only tan. In the fourth one, only cos will give positive value. That's why in on the left side, when tan 3 theta was less than 0, the only place 3 theta could exist was the second quadrant. Now, as tan theta is greater than 0, the places where 3 theta exists is first quadrant and the third quadrant. So now we can write 3 theta is equal to 1.1071, the value for the first quadrant, and pi plus 1.1071, the value for the third quadrant. So this gives us 1.1071 divided by 3 and pi plus 1.1071 divided by 3. Ultimately, this will give us 0.3690 and pi plus 1.1071 divided by 3 would give us 1.4162. Now we have to keep all the values to two decimal places, so we can write 0.37 and 1.142. From here we can see that the values for the solutions of theta are 0.37, 0.72 and 1.42, and this is our answer. This is our answer for this part. So this concludes our question number 8. We can now move on to question number 9.
Let me guess. You are watching videos, taking notes, maybe even grinding late at night. But the marks, they are just not going up. You are stuck, and it's frustrating. But here is the truth, it's not your fault, it's the method. And that's exactly where Exam Essentials makes the difference. We at Exam Essentials actually offer two very powerful courses to navigate you towards success. The first one is the most popular high impact crash course. If you are just 4 to 6 months away from your exam, this course is going to be a lifesaver for you. And the second course that we at Exam Essentials actually offer is the complete 1 year course. This is basically for the students who want full support from day one to exam day. And the best part, our students' results speak for themselves. Both the courses are actually open ahead of every exam session. No matter whether you are going to give your exam for the May 26, Jan 27, May 25, or October 25, doesn't matter. We always offer these two courses before every upcoming exam session. To join or know more, just check the description box below. You will find our WhatsApp number and Facebook page link right there. Let's turn your effort into results together.
So here is our question number 9. We can see that here the figure 2 shows a sketch of the curve C with equation x equals to 2 by 3 sine 3y plus pi by 4. So this is our equation for which the graph is given, and the domain for y is also given. We can see that y starts from pi by 12. So that is where our graph starts, at y equals to pi by 12. Now we can see that it is given that the curve intersects the y-axis at points A and B as shown. Now for part A, we have to find the exact value of the y coordinate of point A and point B. Now we can see here that point A and B are the intersection points for the y axis. What this means is that at these points x is equal to 0. We can use this information to find the coordinates for y. Now we will use this information to find the y coordinates of point A and B. We can write at A, B, x is equal to 0. So we can write 0 is equal to 2 by 3 sine 3y plus pi by 4. This is our expression, and we have substituted x equals to 0 in our equation. Now to find the value of y, we have to make y the subject of this expression. To do that, we will first divide the whole function by 2 by 3. So this will give us 0 equals to sine 3y plus pi by 4. Now again we can make sine 3y plus pi by 4 as the subject of the expression, and then I can find the basic acute angle for this. Now we know that the values of angle at which sine function becomes 0 are 0, pi, and 2 pi, and many others. The values that will be valid for this particular question needs to be within the range given. We already know that y is greater than pi by 12 but less than 3 pi by 4. So this is the range given for y. We have to calculate the range for 3y plus pi by 4. To calculate the range for 3y plus pi by 4, we first will multiply each part of this range with 3. So 3 into pi by 12 is less than 3y, which is less than 3 into 3 pi by 4. Now what we will do is we will add pi by 4 to every part of our range. So we are adding pi by 4. So 3 by 12 pi plus pi by 4 is less than 3y plus pi by 4, which is less than 9 pi by 4 plus pi by 4. Now this will give us pi by 2 is less than 3y plus pi by 4, which in turn is less than 5 by 2 pi. What we see from here that 3y plus pi by 4 exists between this range. The value of 3y plus pi by 4 does not exist beyond this. So 0 cannot be a solution for 3y plus pi by 4. So 0 is not applicable here. The other two is applicable. So we can write 3y plus pi by 4 is equal to pi and 2 pi. Then again we can write that 3y is equal to pi minus pi by 4. We are only choosing two solutions. There are many other solutions even within this range, but we are not choosing them because we only need 2 points. Specifically, we need the first 2 points within our period, within our range. We need the first 2 points within our range because the first 2 points would be A and B. So now we can write 3y equals 2 pi minus pi by 4 and 2 pi minus pi by 4. So 3y will be equal to 3 by 4 pi and 7 by 4 pi. So y will be equal to pi by 4 and 7 by 12 pi. This is the answer to our question. So we can write that the y coordinate of A and B is pi by 4 and 7 pi by 12. Seven by 12 pi. Now for part B, we have to show that dy by dx whole square equals to 1 by p minus q x square, where p and q are integers to be found. So we have to show that dy by dx square will equal an expression in this format. So if we differentiate this expression, we can see that in this expression, x is the isolated term. There is no factors multiplied to or added to our variable x. X is the isolated term in this expression. So what we can do for our convenience is we can differentiate with respect to y, and then we can work our way around to find the dy by dx for this expression. So we are going to do that. We know that our expression is x equals to 2 by 3 sine 3y plus pi by 4. This is our expression. We can find dx by dy as 2 by 3 cos so dx by dy would be 2 by 3 the dy by so ddy of sine 3y plus pi by 4 would be cos 3y plus pi by 4 into the differentiation with respect to x with respect to y of 3y plus pi by 4. We need to multiply the derivative of 3y plus pi by 4 because of chain rule, because we have assumed that because we have assumed that what is between the brackets is x. That's why we have to differentiate with respect to y for this expression. Now we can simplify this. This will give us the differentiation of 3y plus pi by 4 would be 3 into 1 plus 0. So 2 by 3 into 3 cos 3y plus pi by 4, and simplified form would be 3y plus pi by 4. So dx by dy in a simplified form is 2 cos 3y plus pi by 4. Now we have to find dy by dx. To do this, we will just inverse our whole expression. So 1 by 2 cos 3y plus pi by 4 is equal to dy by dx. We know from the question that we have to find the dy by dx whole square. So what we are going to do is we are going to square both sides of this equation. So dy by dx whole square is equal to 1 square divided by 2 square into cos square 3y plus pi by 4. Now we know that sin square x plus cos square x is equal to 1. We know this identity. From this identity, we can see that x cos square x is equal to 1 minus sin square x. From this, we can see that this identity is true. Now, we can use this identity in our expression and write cos square 3y plus pi by 4 as 1 minus sin square 3y plus pi by 4. We are going to do that. So we can write 4 into 1 minus sin square 3y plus pi by 4 is equal to dy by dx whole square. Then again we can simplify, we can expand the brackets, and this will be equal to sine 3y plus pi by 4 squared. We know that x is equal to 2 by 3 sine 3y plus pi by 4. From this we can see that 3 by 2x is equal to sine 3y plus pi by 4. So this ultimately shows us that we can replace sine 3y plus pi by 4 with 3 by 2x, and this is what we are going to do here. So 4 minus 4 into 3 by 2x whole square. Simplifying this will give us 4 minus 4 into 9 by 4 x square. Ultimately, what we get as the final expression is 4 minus 9x square. And this is our final expression for dy by dx whole square. From this final expression, we can see that p is equal to 4 and q is equal to minus 9. I'm sorry, q is equal to 9. Now, for part C, we can see that I'm sorry, we have to show the question for C. The normal to C at A and the tangent to C at B intersect at the point D. Using the answer to part B and the sketch of the curve C in figure 2, we have to find in the simplest form the exact x coordinate of D. If you want to visualize this, the question says that there is a tangent to B. So there is a tangent at the point B. So this is the tangent at the point B that the question is referring to. The question also says that there is a normal at point A. So this is the normal at point A. This is the normal to point A. And the question says that the intersection points of these two different lines is what is called as D, and we have to find the x coordinate of the intersection point for these two different lines. Now we can see from the graph itself that the point D is just the intersection point for these two straight lines. So if we know the equations for these two straight lines, we can use elimination method or substitution method to find the x coordinate of D. This shows us that we just need to find the equations for the tangent at B and the normal at A. If we can find these two equations, we can find the x coordinate of D. So to find the equation of tangent at B, we need to find the gradient of that tangent. And to find the normal at A, we need to find the gradient of that normal. So in part C, in part C, uh, in part C, we have to find the equation of the tangent and we have to find the equation of the normal. To find the equation of the tangent, we need to find the gradient of the tangent. As the tangent is a tangent at point B, then we can say that the gradient of tangent at B will be equal to the gradient of the curve at point B. So the gradient of tangent at B will equal the gradient of the tangent will equal the gradient of the curve at B. So we will find the gradient of the curve at B, and that will give us the gradient of the tangent. To find the gradient of the curve at B, we will use the x coordinate of B. We know that the x coordinate of B is 0. X equals to 0. We can say at B x equals to 0. We know that dy by dx whole square is equals to 1 minus 4 minus 9x square, or 1 minus 4 minus 9 into 0 square, or 1 by 4. So dy by dx at x equals to 0 is root over 1 by 4 plus minus root over 1 by 4, or plus minus half. From our sketch, we can see that the tangent to B has a positive gradient. The tangent to B has a positive gradient because it makes a positive angle. Because it makes an acute angle with our x-axis. The tangent to B makes an acute angle with our x-axis. That's why the tangent to B will have a positive gradient. That's why we can say that the gradient of the tangent will equal half, because the gradient of the tangent is positive. So we can now find the equation of the equation of the tangent. The equation of the tangent will be y minus y1 equals to mx minus x1. Here m is half, and the point through which the tangent passes through is B. The coordinates of B is 0, 7 by 12 pi. Putting this information into their respective places will give us y minus 7 by 12 pi equals to half x minus 0, which means that y equals to half x plus 7 by 12 pi. I can write more clearly. So I will write y equals to half x plus 7 by 12 pi. This is the equation for the tangent. Now if we want to find the gradient of the normal at A, so gradient of normal at A. To find the gradient of normal at A, we first have to find the gradient of the curve at point A. Again, we can write at point A, x is equals to 0. We already saw from our previous calculation that dy by dx at x equals to 0 is plus minus half. Again, we can see our sketch, and we can see that at x equals to 0, the gradient at point A is negative, because the angle it makes with the x-axis is obtuse. The angle made with the x-axis is obtuse, so the gradient at point A is negative. The gradient at point A is negative. So we can say that gradient at A equals minus half. So the normal at A, we can say that the gradient of the normal will be equal to minus 1 minus half, which is equals to, so the equation of normal would be y minus y1 equals to mx minus x1. We know that m is 2, and the point that we need to use is A, which is pi by 4. I'm sorry, it is 0 and pi by 4. So this gives us this is the equation of the normal. Now we are told to find the intersection point between the normal and the tangent. So we can now equate the two equations to find the intersection point. We know the equation of tangent is y equals to half x plus 7 by 2 of pi. And we also know that y equals to 2x plus pi by 4. We can make equal these two equations. This will give us 7 by 12 pi minus pi by 4 equals to 2x minus half x. Further simplification will give us 1 by 3 pi equal to 3 by 2x. So x is equal to 2 by 9 pi. And this is our answer. And this is the x coordinate of D. X coordinate of D. So this is our answer to part C. And this concludes our question number 9. We can now move to question number 10. We can see here we have a modulus function. We have a graph of a modulus function. Here we see that figure 3 shows a sketch of a part of a graph with equation fx, where fx is equals to kx minus 10 in modulus plus k, and k is a positive constant. Now some properties about the graph is given. The graph cuts the y-axis at point A. So y-axis is the y-intercept of the graph, and the graph has a vertex at point P. So point P is the vertex of our graph. Now for part A, we have to find in the simplest form in terms of k the y coordinate of A. We know that A is the y-intercept. We know that A is the y-intercept. That's why x is 0 at A. So we can use this information to find our value of k, to find our value of y coordinate of A. So for part A, we can write, for part A, for part A1, we have to find the y coordinate of A. To find the y coordinate of A, we will use the information that at y-axis x equals to 0. We know our equation is kx minus 10 plus k. So we can substitute x equals to 0 in our equation. This will give us k into 0 minus 10 plus k, which is minus 10 in modulus plus k. My 10 plus k equals to y. And this is the y coordinate of A. So we can write the y coordinate of A is 10 plus k. Now for part 2, we have to find the vertex. We have to find the vertex P. To find the coordinates of the vertex, we can equate the modulus part of fx with 0. When the modulus part of fx will equal 0, the value of x at which the modulus part of fx will equal 0 will be the point at which uh, the vertex is present. So let us calculate the value of x for which kx plus 10 is equal to 0. So I can write kx plus 10 is equal to 0, or kx is equal to minus 10, and x is equal to minus 10 by k. So this is the x coordinate of our vertex. This is the x coordinate of our vertex. For the y coordinate of our vertex, we can use the same property. We know that at our vertex, the uh, the term inside the modulus is equal to 0. So we can use this information to find y at our vertex. So 0 plus k, which is equal to k. So y equals to k. So at our vertex P, y equals to k and x equals to minus 10k. So minus 10k and k is uh, the coordinates of the vertex. This is our answer for part A. For part B, we can see that we have to find in terms of k the range of values of x which satisfies this inequality. We will first write out the inequality. The inequality is kx minus 10 kx minus 10 plus k is greater than 2k. Now if if you want to solve this inequality, there is mainly two ways of doing this. One of them is just generally breaking down inequalities, and the other way is squaring the inequalities. We will use the first method. So I can isolate the modulus. This will be equal to 2k minus k. Now I can further simplify, and ultimately I get this. Now I can write this as kx minus 10 is greater than k, or minus kx minus 10 is greater than k. There are two possibilities. One is for when kx minus 10 is positive, and another is for when kx minus 10 is negative. So from this, we can find the value of our inequality. We can try to solve our inequality. So we can write kx is greater than k plus 10, or x is greater than k plus 10 by k. And for this inequality, for the other inequality, we can simplify. Minus kx plus 10 is greater than k, or minus kx is greater than k minus 10, or x is less than equal to k minus 10 divided by minus k. Notice here we have changed the sign. We have changed the sign from here to here because we are dividing by minus k. When we divide by minus k, when we divide by negative, we know that we have to change the sign. So we have changed the sign of the inequality. Now upon further simplification, we get that 10 minus k divided by k is our solution. So from this we can write that 10 plus k divided by k, x is so this is our solution to the so this is our solution, that x is either less than 10 minus k by k, or x is greater than or equal to 10 plus k by k. So this is our solution to the inequality. For part C, we can see that it is given that the line with equation y equals to 3x plus 1 intersects the graph of y equals to 5x at two distinct points. We have to find the range of values of k. So we can see that it is said that there is a line that intersects the graph at two distinct points. From here, from the graph, even from the graph, we can see that there is a maximum and minimum value for k for which this is possible. Let's say the value of k is such that the line lies on our vertex. In such a case, there will be only one solution. There will be one solution to their intersection. There will be one intersection. That's why there will be only one solution. That's why our value of k must be greater than this value of k. And there is also a maximum value to this. Let's say our value, let's say the graph has such a value of k such that there is no intersection at all. So these are the extremes of the minimum values for k, the maximum values for k, and we need to find them. Now at the minimum value of k, the modulus function will intersect only one time with our line. So if that is the case, we can substitute the coordinates of P which is 10 by k and k, and we can substitute this into our equation of y equals to 3x plus 1. So this gives us 3 into 10 by k plus 1 equals to k. So k equals to 30 by k plus 1, and k is equal to 30 plus k by k equals to k, and this will give us k square minus k minus 30 is equals to 0. Now if we solve for k square minus 5x minus 6 minus 30 will be equal to 0. I'm sorry, this would be plus. So we can write, I have to rewrite this equation. So we can write that k square plus 6k, I'm sorry, minus 6k, minus 6k plus 5k minus 30 is equal to 0. So we can find that k is common between first two terms, and 5 is common between the last two terms. So k plus 5 into k minus 6 is our factor. So k equals to minus 5 and k equals to 6. These are the two values. We already know that k is not equals to 5, and from here we understand that k equals to 6 is the maximum value of k. Is the maximum value of k. It is the reason, the point at which our value of k will be maximum is k equals to 6. So we can write that maximum value of k occurs when our equation y equals to 3x plus 1 passes through the vertex. That would be the maximum value of k. Any other value has to be less than that. Now this is the maximum value of k. What about the minimum value of k? The minimum value of k must be greater than k also must be greater than 3. The maximum value of k is 6, and the minimum value of k is greater than 3. The reason why k is greater than 3 is because at k equals to 3, both the line and the modulus function are parallel to each other. This means that there will be only one solution to the there will be only one intersection point to the curves, thus making the prediction false, making the condition false. And the reason why k has to be greater than 3 is because any other value that is less than 3 will produce a graph that will never intersect with the line. Any value that is greater than 3 will eventually intersect with the line. That's why our value of k must be greater than 3, but has to be less than 6. So our solution is k is greater than 3 but less than 6. Again, the reason why it is less than 6 is because when k increases, the height of the graph also increases. So as k increases, the stretch of the graph, the widening angle of the graph also increases, and the height of the graph above the x-axis also increases. Now that's why k can only increase to a certain point. In our case, k can only increase up to 6, because at k equals to 6, the graph reaches to such a point that above k equals to 6, the graph will no longer intersect with the line, or intersect only one time. That's why the maximum value of k will occur at the point at which the line passes through the vertex, and the minimum value occurs at x equals to greater than 3. So this is our answer to question number 10. So this concludes our question number 10, and also this concludes our paper.